All right, here we go. I just want to quickly, we're going to get started real quickly on the 5.1, but I wanted to let you know that this may actually go into two videos, so we might have a part one and a part two. I'm going to try to keep it under 25 minutes total, but this is kind of a more complicated section. So if there is two videos, just be prepared for that. I also want to explain things a little more detailed than what Miss Wilson did on her video, so that way you kind of have a little bit better understanding of this section as you do your homework. All right, so let's go ahead and get started. We're going to talk about the mid-segment theorem and a coordinate proof. Okay, it's again a coordinate proof. It's slightly different. It's not a two-column proof, so no worries about that. Just be prepared. You'll see it's not necessarily easy, but it's different than a two-column proof. So let's get started. So a mid-segment connects the midpoints of two sides of a triangle like this right here. So here's two sides of a triangle. This is this section, right? So those are the two sides of the triangle we're talking about now. This right here is the mid-segment, okay? So here's the midpoint, and here's the midpoint of each side. So KC is congruent to CA, and KD is congruent to DB, and this little segment connects that, okay? Now what you're going to find out is that the mid-segment is always half of the third side of the triangle, okay? So here's the third side of the triangle that hasn't been used for anything, and the mid-segment is half of that. No matter what I do here, okay, it's a little bit off right now. But here you have 6 and 12. It's off because of the fraction. They're not putting the decimals up there. So there's your mid-segment, okay? So the mid-segment, again, is the segment that connects the midpoints of the two sides of a triangle, and it is half, you might want to write all that down, it is half of the third side. It's half of this side here. So CD is half of AB. So you need two CDs in order to fit on AB. So 2 times CD equals AB, or CD plus CD equals AB, or CD equals half AB. You can look at it algebraically a couple different ways. Okay, and again, just take a little bit of notes on that. Okay, let's get started here. Okay, if we're looking at this diagram here, and we see a whole bunch of different triangles, remind you of Sierpinski a little bit? Maybe, no friends. Okay, it's asking what is the measure of EI. So what's the measure of this segment? Okay, well you're given EF, that's the entire segment. Okay, so I'm sorry, let me take that off. EI, this segment here, and you're given EF, which is the entire segment of 4x plus 2, and then you're also given GH, which is 3x minus 5. So how does GH relate to EF? Well, if this is a midpoint here, and this is a midpoint, and these are connected, and that's what we can assume for this particular set of notes. These are the midpoint. H is the midpoint of FJ, and G is the midpoint of EJ. Then we can assume that this is the mid-segment of the triangle FJE, and that this mid-segment is half of this third side, right? So basically, it's related by the fact that two GHs will equal 1 EF. Or I could say 2 times GH equals EF. So I can set that up algebraically as 2 times 3x minus 5 equals 4x plus 2 in order to allow myself to solve for x, because now I can solve for x. Now I have 6x minus 10 equals 4x plus 2. Then I have 2x minus 10 equals 2. Then I have 2x equals 12, so then I end up with x equals 6, right? So now if x is 6, I can plug that in because I'm looking for EI, right? I'm looking for EI. I can plug that in right here because if I is the midpoint of EF, okay, then I know that by definition of a midpoint, EI is half of EF. Well, we already said that GH was half of EF. So essentially, this segment, EI, is congruent to GH. So I could plug this in. 3 times 6 minus 5 is equal to 13. And that was my length of EI. I could also come in here. Let's say you didn't connect the dots. Let's say you didn't realize that GH and EI were congruent. You could also come in here and say, you know what? I'll put 6 in for x. I'll have 4 times 6 is 24 plus 2 is 26. Well, EF is the entire segment. I'll divide it by 2, and 26 divided by 2 is also 13. So a different couple of approaches for that. Okay, different approach for each one. But that's how you find EI, right? Now it's telling you if the perimeter of EJF, so EJF, so the perimeter of this large triangle is 52. What is the perimeter of GIH? Right now, hopefully some of you guys are making a conjecture. Maybe you're saying to yourself something along the lines of, oh, well, if this midsegment here, let me take these off. If this midsegment here is half of this segment, you might also be able to conclude that this midsegment here is half of this segment. And you might also conclude that this midsegment here is half of this midsegment. You have a bunch of halves, right? So maybe what you could say is that if each segment is half, maybe the entire perimeter is half. And if you made that conjecture, you'd be correct. The perimeter is 26 because half of 52 is 26. Okay? As always, if you have any questions, please write those down and bring them to me in tutorial before or after school, because tomorrow we will jump right into the classwork. Again, the effort for this is to get you help that you need in class and also to have less homework. Okay? All right, let's move on to the next. Let's talk about a coordinate proof. This is where it gets a little dicey, if you will. Okay? First one's going to be pretty simple. Coordinate proof basically does this right here. If we can prove something works with a variable, then it will work with values as well. So if we can prove that x equals y, then we know that 4 equals 4, right? I mean, we can prove that. So if we can prove something with variables, we can plug in any number and prove it as well. So here's what we're going to do. Anytime you're trying to prove something, okay, you want to try to, especially when you're doing a coordinate proof, you want to try to stick that first place at 1. Okay, I want to place a point there at 1 because that vertex gives me 0, 0. Okay? And what I'm working with right now is a rectangle. That's the proof I'm working with. Okay, so I'm going to put a point here on 0, 0, and I'm going to try to use as much of each axis as possible because I have those zeros. Those zeros will help me. And then I'm going to put a point here on 0k. Then I'm going to put a point here on h0. Okay, if I have these points, what can I say this point is called? Yeah, this is hk. It's over h, it's up k based on everything else around it. All right, so essentially what we did here is we proved that in a rectangle, on a coordinate or anywhere else for that matter, that this point right here has the same x value as this, but the same y value of this. So anytime you want to put in a figure here now, when you're figuring this out, you can put numbers in here. So if this is 0, 4, and this is 4, 0, you know hk is going to be 4, 4, without having to count or anything else. You can just take that k value and say, oh, it's 4, this is h is 4, and there you go, you're all set. Okay? So rectangles are slightly easier. Now let's get into one that's a little more challenging. Okay, I'll hide those so we can talk about those in a minute. So now, let's look at this. What if I wanted to prove that this is the midsegment of this particular triangle? And in particular, this is half of this segment here. Well, I started off by putting a point at my origin. Like I said, use your origin and your axes as much as possible. So I have a point at my origin and a point at 2p, comma 0, and I use this, or we're using this 2p here to make the math easier, because if I want to find the midpoint of something, how do I find the midpoint? What's the midpoint formula? Do you guys remember? Hopefully you remember that it's, your x plus x divided by 2, comma y plus y divided by 2. So this 2p and 2q and 2r is going to make it a little easier for our math here in a second. All right, so if I want to prove, oops, wrong one. If I want to prove that this point right here is the midpoint of 0, 0, and 2p0, excuse me, I would do x plus x, so 2 plus 0, divided by 2. So 2p is 2, 2p plus 0 is 2p, divided by 2, 2p divided by 2 is just p, and then 0 plus 0 is 0, of course, so this is going to be p0. Okay? Now, let's look up here. We need this segment to be half p, or p divided by 2, for the total distance, which we'll talk about here in a minute. Okay? Now, what about these? I need these to be the midpoint, right? Let's go to this one first. I'm sorry. Let's do this one first because this one's a little easier, okay? So if I want to find out what the midpoint of this one is, I would do 2q plus 0 divided by 2, which is going to give me q. 2r plus 0 divided by 2, which is going to give me r. So I have q and r. So that's pretty simple. So that the midpoint of this segment is q and r. And again, this is a coordinate proof. That's why we're not using numbers, okay? Because I can put in any number for those later on. Okay, now let's prove this one to be the midpoint over here. Here's where it gets a little more difficult. We have 2q plus 2p, again using that midpoint formula, 2q plus 2p divided by 2. Well, 2p and 2q cannot go together, so then you would just factor out that 2. So 2p plus 2q divided by 2 ends up being p plus q. 2r plus 0 is easy because it's just 2r. 2r divided by 2 is just simply r. So here you have 2q plus 2p divided by 2. Factor out the 2, and you end up with q plus p, and then of course r because you divide that by 2. So here's all of our variables. Okay, here's all of our variables set up for us for some proofs. Now, as we move, we want to prove now that this is 2 times the value of this, or this is half the value of that. So when we have a Cartesian plane, how do we find distance between 2 points? Well, when the points are horizontal like they are, it's pretty simple. You can just simply take the x value. So you can say, okay, this is a distance of 2p, okay, or 2p minus 0, right? Oh, let me go back, sorry. Here we're doing slope. Okay, sorry, I don't want to take one step back. Okay, I'm gonna move forward and prove that this is half of the third side here. But before that, what we're gonna do is we're gonna take the slopes of this line here and this line here just to prove that they have the same slope, which is clear, they're horizontal lines, and so they should have a slope of 0. So if you do the slope formula, which is y minus y over x minus x, okay, you have r minus r is 0, and then you have q plus p minus q, okay, and what happens is r minus r is 0, so anything under that, that's going to be a 0 slope. 0 divided by anything is 0. And then here, if you take the bottom line, you're going to have 0 minus 0, and 2p minus 0. Well, 0 minus 0 is 0, so these both have a slope of 0. Okay, again, that's just proving that they're horizontal, and then on top of the fact they're horizontal, since they have the same slope, they're also parallel. So now, to find out if these are actually the distances that we need them to be, then what we're going to do is we're going to just count. We're going to simply count, like I said a second ago. Because they're horizontal, all I have to do is count. So what I'm going to do is, I'm going to say, okay, 2p minus 0, because that's the origin, that's my final destination minus the origin, is equal to 2p. Here, I have q plus p minus q. I'm only looking at the x values because that'll tell me my distance. So q plus p minus q, those q's cancel out and that gives me p. Is p half the value of 2p, or is 2p twice the value of p? Absolutely. Okay, so now we've proved that the midsegment is actually half of the third side. Okay, and once we prove that for one,